The North Sea sits in the middle of modern certainty. Its coastlines are mapped, its storms monitored, its shipping lanes traced down to the meter. Satellites pass overhead every few minutes. Forecast models refresh constantly. Radios hum with updates no older than a breath. And still, this water kills. Not far from shore, waves rise too fast for escape. Swells stack instead of spreading, building vertical force where there should be room to run. Instruments have recorded walls of water here that physics once insisted could not exist, waves that formed in minutes where models predicted hours. Cold waits beneath the surface, not dramatic, not gradual. A body entering these waters loses strength before it loses panic. Muscles seize, breathing fragments. Even with flotation, movement can fail in less than 2 minutes. The seabed tells the longer story. Tens of thousands of shipwrecks rest below, many without names, many without records. Steel hulls sit beside wooden keels. Some vanished in storms, some struck mines that never detonated again. Others simply disappeared into conditions that never allowed a warning. Tonight, we are traveling into one of the most studied seas on Earth, a place where knowledge does not guarantee safety. But before we begin, if you enjoy these calm explorations into Earth's hidden forces, I'd love it if you gently tapped like or subscribed. And if you feel like it, tell me where you're listening from and what time it is for you right now. So now take a deep breath, let your shoulders relax, and together let us drift into a sea where crossing it has never meant control. The North Sea begins as a space of quiet geography rather than spectacle. On a map, it rests between familiar outlines, pressed gently between northern Europe and the open Atlantic beyond. It looks contained, almost domestic, bordered by coastlines shaped by centuries of settlement and trade. Nothing in its scale suggests excess. Its size feels manageable, its position comprehensible, its waters crossed so often they appear woven into daily life. But placement in the natural world is never passive. To the west lies the full reach of the Atlantic, a body of water that carries energy across thousands of kilometers without interruption. Storm systems form there with time to mature, gathering momentum across open fetch where nothing breaks their stride. When these systems reach the edge of Europe, they do not encounter a barrier. They arrive directly at the mouth of the North Sea, still intact, still carrying the force accumulated far beyond the horizon. The North Sea does not absorb this energy gently. Its basin acts like a narrowing channel, guiding movement inward instead of outward. Winds that once spread across immense distances are compressed into a space with fewer exits. Weather systems retain their structure longer than expected, moving through a sea that cannot disperse them sideways. Pressure gradients sharpen, and transitions that feel gradual in the open ocean become abrupt once confined. Latitude adds further tension. Positioned high in the northern hemisphere, the North Sea lies beneath intersecting air masses that rarely settle into equilibrium. Cold polar air slides southward, while warmer systems rise from lower latitudes, meeting above a shallow basin that responds quickly to changes overhead. Temperature contrasts sharpen fronts. Energy transfers downward with little delay. The sea reacts almost immediately to what passes above it. Unlike deeper oceans, this basin cannot hide from the atmosphere. Its average depth is modest, which means winds transfer momentum efficiently from air to water. Waves respond faster, surfaces roughen sooner. The sea does not buffer incoming force through depth. Instead, it reflects and amplifies it, returning motion upward rather than allowing it to sink and fade. This geographic arrangement creates a place that feels perpetually unfinished. Weather does not arrive fully resolved. It keeps evolving while already in contact with ships, rigs, and coastlines. Systems slide through, collide, and redirect with little warning, shaped less by distance than by confinement. The North Sea does not generate its own violence in isolation. It receives, concentrates, and releases the energy of much larger systems passing through a much smaller stage. What emerges from this position is not unpredictability born of chaos, but instability born of compression. Forces arrive already strong and are given nowhere to go. The sea becomes a meeting point for momentum that never learned how to slow down. The moment usually begins without warning, not with towering walls of water on the horizon, but with an ordinary surface already in motion. Waves roll in familiar patterns, crests rising and falling within expected limits. Instruments register nothing unusual. To the eye, the sea looks busy but manageable, a textured surface shaped by wind and distance. Then, within seconds, the pattern collapses into something else. A rogue wave is not a single wave traveling alone across the sea. It is a sudden concentration of energy, a brief alignment of forces that pulls surrounding motion into one towering form. Smaller waves do not vanish, they are folded together, stacked by chance timing and direction until one crest grows far beyond what the surrounding conditions suggest. This wave is steeper, taller, and heavier than its neighbors, rising sharply before gravity can smooth it away. It does not announce itself through gradual buildup, it simply appears, already formed. For centuries, such waves existed only in stories passed between sailors, described as walls that rose where no storm should have produced them. Science dismissed these accounts as exaggeration, shaped by fear and imperfect memory. That certainty quietly ended in the North Sea near the end of the 20th century. An offshore platform known as Dropner carried laser instruments designed to measure wave height with precision. On a winter night, these sensors recorded a single wave far larger than any model predicted, rising abruptly from surrounding seas that remained within expected limits. The data left no room for interpretation. The measurements showed a crest nearly twice the height of the waves around it, emerging in conditions that theory said could not produce such extremes. This was not a distant anomaly in an unmonitored ocean. It was recorded in real time in one of the most measured seas on the planet. What sailors had long described as rare but real was now fixed into numbers and timestamps. These waves arrive without warning because their origins are fleeting. They are born from interactions that exist only for moments. Currents moving against wind shorten wavelengths. Reflected energy from shallow boundaries overlaps incoming wave trains. Differences in wave speed cause faster crests to overtake slower ones. When timing aligns just long enough, energy concentrates upward instead of spreading outward. The process does not leave a long signature. By the time instruments register the peak, the conditions that created it may already be gone. In the North Sea, this instability is sharpened. Waves approach from multiple directions as weather systems shift and currents turn. Energy reflects off shallow regions and returns into active wave fields. The sea rarely settles into uniform motion. It exists in constant adjustment, with patterns sliding over one another instead of locking into predictable rhythm. A rogue wave is not the sea breaking its laws, but briefly revealing how flexible those laws can be. Physics holds, yet outcomes stretch far beyond intuition. The surface returns to order almost immediately afterward, leaving little trace of what just occurred. Ships pass through the same region hours later, under ordinary conditions, unaware that the water there once rose into a shape that defied every expectation placed upon it. The sea does not need time to become dangerous here. Motion builds before it can be recognized, rising not through distance, but through accumulation. A wave begins as a simple transfer of wind into water, a low movement sliding across the surface. In deeper oceans, that energy has space to spread downward and outward, thinning as it travels. Height arrives gradually, shaped by long fetch and steady forcing. In this basin, the process is compressed. As waves move into shallower water, the lower portions of each swell begin to feel the seabed. Friction slows the base while the upper part continues forward, forcing the wave to steepen. Energy that once traveled horizontally is redirected upward. Each passing crest lifts more sharply than the last, not because the wind has strengthened, but because the sea beneath it has grown restrictive. Depth becomes a boundary rather than a buffer. This stacking happens quickly. Reflected energy from previous waves returns into incoming motion instead of dissipating. Currents moving beneath the surface alter wave speed, causing faster crests to overtake slower ones. What would be minor interactions in deep water become significant in a shallow basin, where there is little vertical space for adjustment. Height increases over short distances, and the surface roughens in minutes rather than hours. For vessels moving through these conditions, escape is an illusion shaped by expectation. Ships are built to outrun storms that develop gradually, where waves grow as systems travel across open ocean. Here, the sea does not wait for pursuit to begin. Growth occurs around and beneath a vessel at the same time. A ship may hold course under manageable conditions, only to meet waves that double in height within the length of a single crossing. Speed offers no advantage when wave patterns are reorganizing faster than navigation decisions can be made. Engines respond to surface conditions that have already changed. Hulls designed to ride predictable periods meet crests arriving out of sequence. The rhythm that ships rely on for stability dissolves, replaced by uneven intervals and steep faces that strike before motion can be corrected. Unlike towering swells that arrive with long warning in open water, these waves feel immediate. Their faces rise abruptly, their spacing shortens, and their force concentrates close to the surface. A vessel attempting to turn away must contend with water that resists redirection, pushing back with reflected energy rather than yielding to passage. Momentum belongs to the sea, not the craft moving through it. The rapid growth of waves here is not a sign of extraordinary weather, but of ordinary forces acting in confined space. Wind does what it always does, transferring motion into water. The difference lies in where that motion is allowed to go. With depth limited and boundaries close, energy has only one direction left. It rises, steepens, and closes distance quickly, leaving little margin between routine movement and conditions that overwhelm even those designed to endure them. Depth changes the character of water long before it changes its appearance. From the surface, the North Sea often looks expansive and open, a wide field of moving gray that gives little hint of what lies beneath. Yet beneath that surface, the distance between sky and seabed is shorter than intuition expects. Compared to the great oceans, where depth stretches into kilometers, this sea is defined by closeness. Water here lives in constant awareness of the ground below it. The average depth of the North Sea is modest when set beside deeper basins. Large portions rest at depths that barely allow waves to pass without interference. This proximity alters behavior at every scale. Motion cannot sink far before meeting resistance, and energy that would normally diffuse downward is forced to remain near the surface. The sea becomes reactive, responding quickly and forcefully to every push from wind and current. In shallow water, waves are never entirely free. Their lower sections drag against the seabed, slowing as the upper portions continue forward. This imbalance reshapes the surface again and again, sharpening crests and shortening wavelengths. Where deep seas stretch movement over time and distance, shallow seas compress it. Small changes accumulate rapidly, turning ordinary motion into something harsher without requiring extraordinary conditions. Aggression here is not born from chaos, but from confinement. Energy enters the system continuously, carried by wind, storms, and distant swells. In deeper oceans, much of that energy is absorbed, dispersed into layers below the surface where it fades quietly. In the North Sea, there is little space for that absorption. Instead of being swallowed by depth, motion returns upward, reflected back into the active surface layer. This reflection creates a restless feedback loop. Waves rebound from shallow banks and uneven seabeds, re-entering moving water instead of vanishing. Incoming energy collides with what has already been redirected, stacking force upon force. The surface grows complex, filled with overlapping patterns that resist settling into steady rhythm. Even when winds ease, the water continues to move with memory, carrying the echoes of energy that had nowhere else to go. The seabed itself is irregular, shaped by ancient glacial paths and shifting sediments. These variations scatter energy unevenly, focusing motion in some regions while leaving others briefly subdued. Such contrasts sharpen local conditions, producing sudden changes over short distances. A vessel may move from relative calm into heavy motion without clear transition, not because the weather has changed, but because the depth beneath it has. In this environment, violence is not constant, yet it is always available. The sea does not need prolonged storms to reach intensity. It only needs input. Wind transfers energy into water, currents guide it, and shallow depth ensures it remains near the surface. What results is a sea that feels tightly wound, quick to respond, and slow to release what it has gathered. Calm becomes temporary, not because forces disappear, but because they are always waiting close to the surface, ready to rise again. Motion in the North Sea is layered, not unified. What appears on the surface is only a thin expression of activity moving in different directions at once. Wind pushes from above, setting the skin of the water into motion, while beneath it, currents follow paths shaped by tides, coastline, and seabed contours. These forces do not align neatly. They intersect, slide past one another, and occasionally press directly against opposing flow. Wind-driven waves respond quickly to changes in the atmosphere. Their direction reflects what is happening in the air at that moment, shifting as systems pass overhead. Currents, however, carry longer memory. They are guided by tidal cycles that continue regardless of weather, moving water along established routes with steady persistence. When wind-driven motion meets these underlying flows, energy no longer travels cleanly across the surface. It is stretched, bent, and reshaped from below. Opposing movement shortens waves. When a current runs against the wind, the forward motion of waves slows at their base while their crests continue to rise. Spacing tightens, height increases, and the surface grows steeper without any change in wind strength. This interaction is subtle at first, almost unnoticeable, until waves lose their familiar rhythm and begin to crowd together. The sea feels unsettled, not because it grows louder or darker, but because it stops moving in predictable intervals. Beneath the surface, these interactions multiply. Different currents occupy different depths, sliding past each other like overlapping sheets. Some are shaped by tides flowing in and out of narrow passages, others by water density differences linked to temperature and salinity. Where these layers meet, friction and shear transfer energy upward. The surface receives this influence indirectly, responding with irregular motion that seems disconnected from the wind above it. This hidden complexity breaks the idea of a single wave field. Instead of uniform motion spreading across the sea, multiple patterns coexist, intersecting without coordination. Waves arrive from different angles, their crests crossing rather than following in orderly lines. Reflected energy from shallow regions re-enters these patterns, adding further distortion. The surface becomes a mosaic of competing movements, each governed by different forces beneath. For those moving across it, the result is confusion rather than escalation. There is no clear direction of travel for the water itself. A vessel may ride one wave forward while being pushed sideways by another, then slowed abruptly as opposing motion rises underneath. The sea resists alignment, responding differently from moment to moment without signaling transition. This chaos is not random. It emerges from structure, from the consistent presence of forces that rarely agree. Wind reacts to the sky. Currents obey cycles deeper and older than weather. Where they meet, the sea cannot choose a single response. It expresses all of them at once, folding movement into itself. The surface becomes restless not because it lacks order, but because too many orders exist at the same time, each insisting on its own direction. Storms here do not always begin with a long prelude. Sometimes they seem to arrive already shaped, their outlines firm before the sky has finished changing. Clouds thicken quickly, pressure drops without much ceremony, and wind organizes itself into intent rather than hesitation. The transition from workable weather to difficult conditions can pass almost unnoticed until motion on the sea begins to sharpen. This speed is rooted in how weather systems move into the region. Many storms are not born locally but carried inward from far away, arriving with momentum already established. As they cross into the confined space of the North Sea, they do not need time to grow. They compress. Boundaries tighten around them, concentrating wind and forcing rapid adjustment. Changes that unfold slowly across open ocean occur here over the span of hours. The atmosphere above the sea rarely settles into balance. Air masses with different temperatures and histories converge frequently, and their boundaries sharpen once they are constrained by geography. Fronts strengthen rather than soften. Wind fields reorganize with little delay, shifting direction as pressure systems slide past one another. The sea beneath responds immediately, translating invisible changes in air into visible motion on the surface. Forecasting exists within this compression. While large-scale systems can be tracked days in advance, local intensity develops closer to the moment of impact. Small variations grow significant quickly. Timing errors, measured in hours, matter here. A crossing that begins under acceptable conditions may intersect a developing system at its most energetic phase, even when the broader forecast appeared manageable. For crews already underway, this creates narrow margins. Decisions are made based on conditions as they are, not as they will become. Routes commit vessels to exposure long before the atmosphere completes its transformation. Turning back is not always possible once motion steepens, and altering course may place a ship more directly into emerging wind and wave alignment. The sea does not pause to offer reassessment. Mid-crossing, the change feels less like a buildup and more like a rearrangement. Wind stiffens, wave patterns lose symmetry, and visibility shortens as spray lifts continuously from the surface. What was once navigable becomes demanding without clear division between states. Crews find themselves adjusting to conditions that did not exist when the journey began, shaped by a system that matured around them rather than ahead of them. This rapid development leaves little space for anticipation rooted in experience. Familiar signs still exist, but they compress into shorter sequences. The gap between first notice and full expression narrows until recognition and response nearly overlap. The sea becomes active before caution can fully catch up. Storms that appear almost fully formed are not exceptions here. They are expressions of a region where energy converges efficiently and releases quickly. The atmosphere brings motion with it, and the sea accepts it without delay. What results is not unpredictability, but speed. Change arrives already assembled, and those within it must move through a force that finished becoming itself while they were already at sea. Cold remains present here even when the sea looks calm. Seasonal change softens the air above the surface, but water holds memory longer than weather. Through most of the year, temperatures hover well below what the human body can tolerate for long. Summer warmth barely touches the upper layer, and winter draws heat away with steady insistence. The sea does not need ice or storms to impose this condition. Its cold exists quietly, waiting without movement or sound. When a body enters this water, the response begins before thought has time to form. The skin senses sudden loss of heat, and the nervous system reacts instantly. Breath becomes sharp and uncontrolled as reflex overrides intention. Muscles tighten, heart rate jumps, and blood vessels near the surface constrict in an attempt to preserve warmth deeper within. This happens within seconds, not minutes, and it happens regardless of strength or experience. The first danger is not distance or fatigue, but loss of control. Involuntary gasping draws air unevenly, sometimes pulling water inward instead. Fine motor skills fade quickly as cold limits nerve signaling. Hands lose dexterity, fingers stiffen, and simple movements require focus that is already being consumed by the effort to breathe. Even strong swimmers find coordination slipping as the body prioritizes survival over motion. As exposure continues, muscles weaken further. Cold reduces their ability to contract efficiently, shortening range of motion and slowing response. Movements that would be effortless on land demand increasing effort, yet generate less force. The body burns energy rapidly while producing little useful work. Heat loss continues faster than it can be replaced, especially when waves and spray strip warmth from the surface. Flotation changes position, not physiology. It may keep the face above water, but it does not prevent cold shock from unfolding. Breathing remains irregular, muscles remain compromised, and circulation continues to retreat inward. The body still cools. Without insulation, flotation only delays submersion while the underlying processes advance. Time becomes limited, not by exhaustion alone, but by the gradual loss of functional movement. In these waters, survival depends less on staying afloat than on staying warm, a distinction that is easily overlooked. Clothing designed for land absorbs water and increases heat loss once submerged. Protective gear can slow cooling, but only if worn before entry. Once in the water, options narrow quickly as the body shifts from active response to conservation. Cold shock leaves little room for adaptation. Experience offers limited protection because the reflexes involved bypass learned behavior. The sea does not test endurance gradually. It applies constraint immediately, reducing capability before strategy can take hold. What remains is a narrowing window where control fades faster than awareness, shaped not by wave height or weather, but by temperature that never truly loosens its grip on the water. Darkness arrives early here, not as nightfall, but as a shortening of margins. In winter, daylight thins to a narrow band, sliding low across the horizon before retreating again. The sun never climbs far enough to clear the atmosphere cleanly, and light spreads sideways rather than downward. Colors flatten, contrast fades. The sea takes on a uniform tone that erases distance and depth at the same time. As light weakens, the surface becomes harder to read. Subtle differences between swell and trough dissolve into a moving gray plane. Landmarks that might anchor perception blur or vanish altogether. Even familiar routes lose definition when shadows stretch across the water and the sky offers little separation between cloud and horizon. Orientation begins to rely on instruments rather than instinct, and instinct no longer has much to work with. Fog deepens this uncertainty. Moist air cools rapidly over cold water, condensing into layers that drift and reform without pattern. Visibility can collapse within minutes, turning the surrounding world into a small, shifting circle. Sound travels farther than sight in these conditions, but without direction. Waves, engines, and wind blend together, creating presence without location. Distance becomes guesswork. Spray adds another veil. Wind lifts water from the surface and carries it sideways, filling the air with fine droplets that scatter what little light remains. This spindrift does not fall quickly. It hangs, moving with gusts, catching illumination and reflecting it back at the observer. The result is a visual field crowded with motion that does not correspond to shape. The eye struggles to separate what is solid from what is passing. Whitewater intensifies the effect. Breaking waves churn the surface into foam that spreads and reconnects, dissolving edges and flattening perspective. The boundary between sea and sky grows indistinct, especially when cloud sits low. Without a clear horizon, balance becomes harder to maintain. The body depends on visual cues to confirm what the inner ear senses, and when those cues disappear, disorientation follows quietly. Loss of spatial awareness does not arrive suddenly, it accumulates. Small misjudgments stack as reference points fade. Direction feels less certain, speed harder to estimate. A vessel may be moving steadily, yet perception suggests stasis, or the reverse. The mind searches for fixed markers and finds none that remain stable for long. In this environment, attention narrows. Focus shifts inward toward immediate tasks, reducing awareness of the wider setting. Instruments provide numbers, but numbers alone cannot replace a sense of space. When visual and physical feedback diverge, fatigue arrives faster, not through exertion, but through constant correction. Darkness, spray, and fog do not need severe weather to take effect. They operate in ordinary conditions, layered together by season and temperature. Their influence is subtle but persistent, reshaping how the sea is perceived. Orientation fades not because the sea changes shape dramatically, but because the cues that once described that shape withdraw, leaving motion without context and movement without clear reference. The seabed here does not lie empty or smooth. It carries weight in another form, layered quietly beneath the moving water. Metal hulls, wooden frames, collapsed masts, and scattered cargo rest in silence, marking paths taken and moments interrupted. This accumulation is not evenly spread. It gathers in patterns, tracing lines that mirror how the sea itself behaves. The density of wrecks across the North Sea is striking. Thousands are known, and many more remain unrecorded, softened by sediment or broken into pieces that instruments only partially recognize. Some date back centuries, others to recent decades, yet time compresses them into the same dark plane. They lie close together in places, as if drawn toward shared ground rather than scattered by chance. These clusters form where routes intersect with resistance. Shipping lanes narrow between coastlines, oil fields, and shallow banks, guiding vessels along similar paths year after year. When weather disrupts control, ships do not drift randomly. they are pushed toward the same margins, carried by wind and current into areas where depth changes rapidly and maneuvering space vanishes. The sea repeats its pressure in the same locations, and the seabed records the outcome. Shallow regions collect wreckage because they magnify failure. Vessels lose options more quickly where clearance is limited and wave behavior steepens. A grounding that might be survivable elsewhere becomes final when motion continues without depth to soften impact. Structures break, hulls open, and remains settle close to where momentum ends. Over time, these areas become dense, with fragments from different eras, layered like quiet sediment. Human factors leave similar traces. Approaches to ports, crossings near headlands, and areas worked heavily by fishing show higher concentrations of wrecks. Traffic increases exposure, but familiarity also plays a role. Routes traveled often are trusted, even when conditions shift. When the sea disrupts expectation, it does so where confidence was highest, leaving remains in places that once felt routine. Conflict added another layer. Mines, scuttled ships, and wartime losses increased density in specific corridors, often the same routes still used today. Explosions and sinkings added debris to areas already shaped by natural difficulty. Even after decades, these remnants influence the seabed, altering currents locally and adding hidden obstacles that complicate navigation and recovery. What these patterns reveal is not chaos, but structure. Danger here is geographic. It concentrates where forces converge, where space tightens, and where decisions narrow. The seabed maps these relationships with precision, outlining zones of repeated stress rather than isolated tragedy. The water above continues to move, erasing memory from the surface. Yet below, the record remains intact. Each wreck is a fixed point in a shifting system, a reminder that the sea applies pressure consistently, even as weather and technology change. The floor beneath the North Sea reads like a quiet archive, showing where motion overwhelms control again and again, and where passage has always carried more weight than it appears. Work begins here before conditions reveal themselves. Fishing vessels move according to cycles older than forecasts, leaving harbor with the routine patience of repetition. Gear is prepared, lines paid out, nets set where generations have learned to look. These boats are small compared to the sea they enter, built for flexibility rather than mass, designed to follow living movement instead of resisting water outright. That design brings exposure. Fishing vessels operate low to the surface, their decks close to moving water, their stability shaped by shifting loads that change hour by hour. Nets fill unevenly, catch weight, moves as the sea moves, and balance becomes something constantly adjusted rather than fixed. Unlike cargo ships that can ride through with momentum, fishing boats must slow, turn, and hold position in places where the sea rarely holds still. Time extends this vulnerability. Fishing requires patience, not passage. Crews remain in open water long after conditions have started to shift, committed by set gear and limited alternatives. Waiting becomes work, and work delays retreat. Storms that reorganize quickly meet vessels already engaged, their focus divided between the sea and the task that cannot simply be abandoned. Historically, loss has followed this pattern. Records show fishing fleets bearing a disproportionate share of maritime fatalities in this region, a quiet arithmetic repeated across decades. Small vessels vanish more easily than large ones, leaving fewer signals and less debris. When they are lost, it is often during ordinary operations rather than dramatic events, during moments that did not register as exceptional until afterward. Many disappear without spectacle. There is no collision reported, no distress message relayed, no wreckage located with certainty. A boat simply fails to return. Weather reports offer no clear culprit. The sea provides no explanation. What remains is absence, folded into schedules and memories with little physical trace. This quiet loss is shaped by the nature of the work. Fishing happens at night, in marginal conditions, at the edges of acceptable weather. Crews rely on experience refined through routine, navigating by feel as much as by instrument. When that intuition is disrupted by rapid change, response time narrows quickly. Gear adds weight and resistance that cannot be shed instantly. Lines entangle, nets drag, winches strain under shifting loads. A sudden wave or turn does not meet an empty deck, but one actively engaged with the sea itself. The boundary between vessel and water blurs as equipment extends into motion beyond the hull. Yet people return to this work continuously. The sea offers livelihood as well as danger, and familiarity breeds persistence. Each successful trip reinforces the sense that knowledge will suffice again. Loss arrives as interruption rather than warning, breaking a sequence that felt stable until it was not. Fishing remains the most dangerous work on this sea, not because it seeks risk, but because it meets the water on its own terms. It stays longer, moves slower, and adapts rather than avoids. In a place where conditions assemble quickly and release without comment, that closeness carries cost, often paid quietly, far from notice, absorbed into the long rhythm of leaving and not always returning. Steel rises from the water here in rigid geometry, vertical lines interrupting a surface that never truly rests. Oil platforms stand fixed, while everything around them moves, their presence defined by permanence in a place shaped by motion. From a distance, they appear calm, orderly, almost indifferent to the sea that surrounds them. Up close, their stillness feels provisional, maintained through constant correction rather than stability. Their placement is not accidental. Beneath this water lies energy of a different kind, locked into layers of sediment shaped over millions of years. The North Sea holds vast hydrocarbon reserves, close enough to shore to be reachable, shallow enough to be drilled with technology available decades ago. Geography made access possible, and economics made it unavoidable. Risk became a condition of extraction rather than a deterrent. Engineering met this risk with scale and calculation. Platforms were designed to absorb force rather than resist it outright. Legs were driven deep into the seabed, structures widened to distribute stress, materials chosen to flex slightly under load instead of snapping. Waves were measured, winds modeled, and currents charted. Design limits were set according to what was known, and margins built for what might occur. Yet the sea has a way of finding the edge of every assumption. Conditions change over time, not just with weather, but with accumulation. Metal fatigues under repeated motion. Foundations settle unevenly as sediments shift. Loads increase as equipment is added and standards evolve. A platform built for one era must continue operating in another, carrying history within its structure. Failures have marked those limits clearly. Some were sudden, triggered by rare combinations of wave height and period. Others unfolded slowly, through unnoticed corrosion or misjudged stress. Investigations that followed did not reveal recklessness, but blind spots, places where experience had not yet reached. Design envelopes proved narrower than expected, not because engineers ignored danger, but because the sea introduced interactions that had not been fully modeled. Each failure altered practice. Standards tightened. Redundancy increased. Monitoring systems became more sensitive, tracking vibration and movement continuously. Escape procedures changed, lifeboats redesigned, operating thresholds lowered, knowledge accumulated through loss rather than foresight, absorbed into regulation and memory. Despite this, platforms remain exposed by nature of their role. They cannot turn away from waves or wait for calmer windows. They must endure every condition that arrives, whether anticipated or not. Their safety depends on remaining within calculated tolerance, and tolerance depends on assumptions that evolve with each passing decade. These structures stand where they do because the resource lies there, and because technology made the reach possible before understanding was complete. They represent a compromise between ambition and acceptance, holding position through constant negotiation with the sea. What they reveal is not dominance, but adaptation. The lessons learned are embedded not only in steel and procedure, but in restraint, in recognition that even fixed giants exist at the discretion of the water that surrounds them. Before the sea carried cables and turbines, it carried convoys. During the World Wars, the North Sea became a corridor pressed into constant use, its surface patterned with routes traced by necessity rather than preference. Ships moved in groups, schedules tightened, and passage grew relentless. What had once been seasonal traffic turned continuous, day and night, across a basin already shaped by compression and motion. Density changed everything. Merchant vessels, tankers, trawlers requisitioned for patrol, and warships shared narrowed lanes, their paths constrained by coastal geography and shallow banks. Speed varied widely, maneuvering room thinned, and separation depended on discipline maintained under stress. Navigation lights dimmed or disappeared altogether to avoid detection, and the visual language of the sea went quiet. Movement continued, but cues thinned and margins shortened. The water absorbed this pressure without distinction. Mines were laid in fields that followed predictable routes, chosen not for their cruelty but for their efficiency. Anchored below the surface or drifting with currents, they turned familiar water into delayed contact. Clearing channels offered only temporary relief as storms shifted seabeds and reset patterns. The sea moved the hazards as readily as it moved waves, rearranging danger between tides. Collisions multiplied in this environment. Reduced visibility, enforced darkness, and crowded passages brought hulls together where open water once allowed avoidance. A minor misjudgment became consequential when escape options narrowed. Damage control occurred amid motion that never truly eased, and vessels already strained by weather-absorbed impact they could not dissipate. Scuttling added another quiet layer. Ships damaged beyond retrieval or intentionally sunk to block routes were set down deliberately, becoming immediate obstacles. These acts were tactical and brief, but their consequences endured. Steel frames altered local currents, disrupted sediment, and changed how waves interacted with the bottom. The sea integrated them into its structure, making yesterday's decision part of tomorrow's conditions. War magnified natural danger by accelerating exposure. Crews sailed in weather that would otherwise delay departure, driven by urgency rather than caution. Repairs were abbreviated, loads increased, and maintenance schedules bent under demand. The sea did not change its behavior, but it encountered vessels pushed closer to their limits for longer stretches of time. Sound carried differently during these years. Engines ran continuously, signaling presence beneath fog and darkness. Explosions traveled through water with clarity that ignored intention. Even in calm periods, tension altered perception, narrowing focus and shortening response. The same mechanisms that complicated navigation in peace now operated under added constraint. When the wars ended, traffic thinned and lights returned, yet the imprint remained. Routes remembered pressure, and the seabed held its record. The North Sea did not become more violent during war. It became more crowded, more constrained, and more burdened with consequence. In that compression, natural forces found more opportunities to overwhelm, revealing how quickly routine can turn unforgiving when necessity presses movement into a space that already resists it. Beneath the modern routes, the seabed carries memory that has not settled. Shipping lanes glide across water that appears renewed each day, yet below the moving surface lie objects placed with intent decades ago and never reclaimed. They do not announce themselves. They rest within sediment, shaped by corrosion and time, altered but not erased. Unexploded munitions remain scattered across large portions of the North Sea floor. Mines, depth charges, shells, and discarded ordnance were laid in quantities that exceeded precise record keeping. Storms shifted them from their original placements, dragging them into troughs or exposing them along banks. Sediment covered and uncovered them repeatedly, pressing steel into silt until outlines softened and edges blurred. Their presence became diffuse rather than concentrated, harder to map as years passed. These remnants still matter because time has not rendered them inert. Chemical compounds remain reactive. Casings weaken, seals fail, and internal materials respond unpredictably to movement or pressure. The danger does not increase suddenly. It persists quietly, changed by age rather than neutralized by it. An object that was once stable on placement may now be more sensitive to disturbance. Modern activity intersects with this legacy constantly. Anchors drag, pipelines are laid, cables buried, and foundations driven into sediment. Fishing gear cuts into the seabed, lifting objects that have not moved for generations. Each interaction introduces motion into spaces that have remained still long enough for danger to feel theoretical. When contact occurs, there is rarely warning. Sound does not precede it. The sea gives no signal that the past has been touched. Seabed instability compounds this risk. The North Sea floor is not uniform or fixed. It shifts with tides, storms, and currents, redistributing sand and clay over time. Channels deepen and refill. Banks migrate slowly but persistently. This movement exposes buried objects and hides others, altering risk landscapes without notice. A route surveyed one year may not match the conditions beneath it the next. Explosions are not required to cause consequence. Even minor releases of energy can damage equipment, rupture pipelines, or compromise structures already stressed by the environment. Shock travels efficiently through water and sediment, translating localized force into wider disruption. In such cases, cause and effect separate in space, complicating understanding after the fact. Mitigation exists, but remains incomplete. Mapping improves steadily, yet full certainty remains out of reach. Detection depends on resolution, interpretation, and access, each limited by depth, coverage, and cost. Avoidance becomes the primary strategy, built on probability rather than elimination. Routes are adjusted, projects delayed, decisions shaped by what cannot be fully seen. The unseen threat beneath modern routes is not active hostility. It is residue, held in place by shifting ground. The sea continues to work its surface with energy and motion, while below, remnants endure as constraints on movement and planning. This layered risk reflects how time does not always resolve danger. Sometimes it disperses it, spreading consequence thinly across a wide floor, waiting for contact that arrives by chance rather than intent. The water here is never simply arriving or leaving. It is always doing both in sequence, drawn by forces that stretch far beyond the horizon. Tides move through the North Sea with strength shaped by its shallow basin and narrowing coasts, rising and falling with enough range to matter not only near shore, but far offshore as well. This vertical motion is slow, patient, and relentless, reshaping the surface twice each day without spectacle. Strong tidal ranges matter because they do more than shift water levels. They set immense volumes of water in motion, creating horizontal flow beneath the surface that can rival wind-driven movement above it. As the tide floods, currents accelerate across banks and through channels, pressing against seabed contours and redistributing energy along familiar paths. As it ebbs, that motion reverses, never fully settling, always replacing one direction with another. This movement becomes consequential when it aligns with weather. Storms bring their own patterns of wind and pressure, shaping waves that travel across the sea with particular timing and speed. When tidal flow runs in the same direction as incoming waves, energy stacks rather than softens. The sea surface grows steeper, crests rise higher, and spacing tightens. What might have remained difficult under either force alone becomes markedly heavier when both act together. Timing governs this interaction. Tides are predictable in isolation, storms less so. When their peaks coincide, conditions intensify over short windows. Currents accelerate beneath waves already pushed by strong winds, limiting the ability of energy to spread. Water that might otherwise pass freely is compressed into moving layers that resist dispersal. The sea grows crowded with motion, not chaotic, but dense. These moments pass quietly into and out of existence. There is no single signal marking their arrival. Instead, pressure increases through small changes that accumulate. Waves begin to feel sharper. Spray lifts more persistently. Progress slows even as engines maintain effort. The sea expresses the added power not through height alone, but through resistance, pushing back against movement in every direction. At peak alignment, escape options narrow. Turning across the flow exposes vessels to uneven forces. Holding course demands greater power, often yielding less ground. The sea does not surge uniformly. It stiffens. Water feels heavier, less willing to move aside. Structures and hulls absorb more energy per encounter, not because waves are suddenly extreme, but because their momentum is reinforced from below. When tide and storm move against each other, the effect shifts but remains demanding. Opposing flows shorten wave periods and steepen faces, producing abrupt motion that challenges balance and timing. Energy still accumulates, redirected rather than canceled. The sea does not neutralize force by meeting it with opposition. It reorganizes it. These tidal interactions explain why the North Sea can intensify without warning even under familiar weather patterns. Power arrives through alignment rather than escalation. The water simply finds moments to work together, stacking movement into brief intervals where ordinary conditions give way to something more concentrated. Then the timing shifts, the tide turns, and the added force disperses, leaving behind a surface that looks unchanged, though it has briefly carried much more than it appeared to hold. Experience here is shaped by rhythm, not constancy. Seasons arrive with recognizable patterns, and those who work this sea learn to read them over time. Winter is known for force, summer for restraint. These broad expectations settle into routine, guiding decisions long before weather charts are consulted. Yet the North Sea does not shift cleanly between states. Its transitions are uneven, and it is within these uneven moments that familiarity becomes unreliable. Winter brings sustained energy. Cold air moves frequently, storms follow one another closely, and the sea remains rarely still. Waves carry weight even during brief pauses, and the surface feels charged with motion that never fully drains away. Crews expect difficulty and prepare for it. Routes shorten, margins widen, and caution governs timing. Violence in winter is not surprising. It is anticipated, accounted for, and respected as a constant presence. Summer appears different. Storm frequency drops, daylight stretches, and the surface often settles into patterns that feel workable. Winds weaken for longer intervals, waves spread out, and movement regains rhythm. This calm is real, but it is not absolute. Energy continues to move through the system beneath the surface, carried by tides and distant weather. The sea does not empty itself of force, it only masks it more gently. False confidence grows in this softness. Familiar routes reopen fully, schedules extend, smaller windows feel safe enough to use. The sea seems to offer cooperation rather than resistance, and experience reinforces that impression with each successful crossing. Memory reshapes expectation, smoothing over the differences between true stability and temporary quiet. The danger emerges when seasons overlap rather than replace one another. Transitional periods bring sudden shifts as atmospheric patterns reorganize. Winter systems linger longer into spring. Autumn sees early intrusions of colder air crossing warmer water. These moments do not announce themselves as seasonal change. They arrive as interruptions to expectation. Accidents spike during these transitions because preparation lags behind reality. Decisions are made using seasonal logic that no longer applies. Crews carry habits forward into conditions that have already begun to behave differently. The sea responds quickly to these shifts, translating subtle atmospheric changes into altered wave behavior and current patterns. The surface may still look familiar when force has already changed beneath it. Tides interact differently as temperature gradients shift. Winds feel manageable until they align briefly with residual energy left from previous systems. These interactions compress risk into short intervals that pass unnoticed until they are fully formed. Experience does not fail here because it is insufficient, but because it is specific. It is tuned to patterns that hold most of the time. Transitional seasons break those patterns quietly. They produce conditions that resemble one state while behaving like another. The sea feels calm while carrying winter's momentum, or restless while wrapped in summer light. In the North Sea, the most deceptive moments are not the harshest. They are the familiar ones, slightly out of place. Seasonal shifts thin the line between knowledge and assumption, reminding those who cross these waters that timing matters as much as strength, and that experience must adapt as quickly as the sea itself. Forecasts begin far from the sea itself. They start as equations, grids of numbers describing air, pressure, and water in motion. Satellites watch cloud tops, buoys feel passing waves, and models translate these signals into projections of what may come next. For many oceans, this distance works well enough. Patterns unfold gradually, and prediction has time to settle. In the North Sea, that distance becomes a limitation. Wave prediction depends on averages. Models are built to describe typical behavior across space and time, smoothing countless interactions into manageable trends. This approach captures the broad state of the sea, but it blurs the sharp edges. Short-lived alignments, brief compressions of energy, and local amplifications often fall below resolution. They exist between data points, forming and dissolving before systems can fully register them. Small errors matter here because margins are narrow. A difference of a few seconds in wave period alters how energy stacks. A shift of a few degrees in wind direction changes how waves interact with currents. Depth variations, measured in meters, reshape surface behavior across large areas. When these factors combine, their effects multiply rather than add. What begins as a minor discrepancy grows into a meaningful change in conditions. The sea translates approximation into consequence quickly. Vessels and structures rely on forecasts, not as abstractions, but as thresholds. Decisions hinge on predicted limits, on expectations of maximum height, speed, or force. When reality exceeds those bounds even briefly, systems designed for tolerance encounter conditions they were not prepared to absorb. Failure does not require sustained extremes, only moments that slip past the envelope of assumption. Part of the challenge lies in scale. The North Sea contains features that operate at lengths too small for global models and too numerous for complete local coverage. Sandbanks shift, currents braid, and reflected energy moves unpredictably across shallow floors. These details influence surface conditions directly, yet they are difficult to represent fully without overwhelming computational complexity. Time adds another constraint. Forecasts update in cycles, while the sea changes continuously. Data gathered an hour earlier may already describe a system that has reorganized. Rapid development compresses the usefulness of prediction windows. Accuracy decays faster than updates can restore it, leaving a gap where conditions evolve ahead of guidance. Science continues to refine these tools. Resolution improves, data density increases, and understanding deepens. Yet, certain interactions remain elusive. Nonlinear wave behavior, sudden focusing of energy, and feedback between surface and depth resist tidy expression. They belong to the realm where order and variability overlap, where rules hold but outcomes diverge. Forecasting still falls short, not because it is careless, but because it is asked to anticipate a system that rewards immediacy. The North Sea responds to alignment, timing, and confinement in ways that compress cause and effect. Prediction approaches certainty from a distance, while the sea operates close to the moment. Between those two perspectives, uncertainty persists, not as failure of knowledge, but as a reminder that some environments change faster than they can be fully described. Familiarity settles quietly. It grows through repetition, through roots traced so often they begin to feel owned rather than borrowed. In the North Sea, these paths are learned early and reinforced constantly. Charts match memory. Buoys appear where expected. Headlands emerge on schedule. Over time, the sea becomes less a presence and more a backdrop, something known well enough to pass through without renewed negotiation. This knowledge brings confidence, and confidence reshapes attention. Known routes feel predictable even when conditions vary. Experience supplies reference points that seem to reduce uncertainty, allowing judgment to move faster and with less hesitation. Decisions once made carefully begin to rely on expectation instead of observation. The sea has been crossed many times before, and that history becomes part of the calculation. Routine sharpens efficiency while softening caution. Tasks are performed smoothly, almost automatically. Checks shorten. Assumptions replace verification. The mind fills gaps with memory rather than current detail. This is not negligence. It is the natural economy of attention, adapting to repetition. Energy is saved by trusting what has worked before. The North Sea amplifies the cost of this trust. Its danger does not announce itself consistently. Conditions can remain workable through many passages, reinforcing the sense that experience equals control. Each successful transit strengthens the belief that the sea behaves within understood limits. The absence of consequence becomes evidence, even when it is only timing. Familiarity also narrows imagination. Rare events fade from consideration because they are rarely encountered. Waves that grow unexpectedly, shifts that happen faster than usual, alignments that concentrate force briefly are remembered as stories rather than possibilities. They exist in awareness, but not in immediate expectation. Planning favors the typical over the possible. Known routes carry another weight. They are often the most trafficked, the most constrained, and the most exposed to compounded forces. Geography channels movement along them, stacking use over time. When conditions shift, there is less room to adapt within these corridors. Escape options feel limited because they are, yet confidence delays the moment when alternatives are considered. Familiar danger becomes most powerful when nothing seems wrong. The sea looks ordinary. Motion feels manageable. Instruments confirm what the eye expects to see. It is within this agreement between perception and assumption that risk sharpens unnoticed. Subtle changes pass without registering as signals, absorbed into the background of normality. Human psychology is well suited to stable environments. It excels at pattern recognition and efficiency. In places where patterns break quickly but quietly, these strengths become vulnerabilities. The North Sea does not punish ignorance as readily as it tests confidence. It waits for moments when attention has shifted elsewhere. Familiarity increases risk not by removing knowledge, but by rearranging how knowledge is used. Experience remains present, yet it speaks more softly than habit. The sea continues to behave as it always has, changing when conditions align. What alters is the lens through which it is read. In that narrowing, danger gains space to grow without being noticed, carried forward by the comfort of knowing where one is. Even as the sea beneath begins to behave differently, change often begins quietly, shaped not by catastrophe but by moments that nearly became one. In the North Sea, safety has been rewritten more by what almost happened than by what fully unfolded. Incidents linger in records and memory, where loss was avoided by narrow margins, where timing or chance held long enough for a different outcome. These near misses share a common quality. They did not announce themselves as extraordinary until afterward. A platform endured waves that arrived steeper than expected but remained standing. A vessel rode through a sequence of impacts that exceeded design assumptions, yet returned damaged rather than destroyed. Crews completed operations under conditions later understood to have crossed safe limits. In the moment, these experiences felt demanding but survivable. Only later did they reveal how close systems came to failure. Investigation begins where routine ends. Data is gathered not to assign blame, but to understand how assumptions met reality. Logs are compared against measurements, eyewitness accounts aligned with instrument records. Patterns emerge where expectations lagged behind conditions. Wave heights exceeded predictions briefly. Wind shifted direction at critical moments. Structural loads accumulated unevenly. Human decisions, reasonable within known parameters, proved insufficient when those parameters shifted without warning. What investigators learned was rarely singular. It was the convergence that mattered. Small factors aligned, compressing stress into narrow windows. Equipment performed within specification yet faced combined forces that specifications had never accounted for simultaneously. Procedures followed correctly but encountered conditions outside their design envelope. Training addressed typical scenarios, while rare interactions passed unpracticed. From these findings, standards evolved incrementally. Design criteria expanded to include broader ranges of wave behavior, not just average extremes. Redundancy increased where single points of failure had gone unnoticed. Monitoring systems gained sensitivity, capable of detecting subtle changes before thresholds were crossed. Operational limits were revised, lowering acceptable exposure in recognition of how quickly conditions could escalate. Human factors entered these revisions as well. Shift lengths adjusted to reduce fatigue. Communication protocols clarified to reduce assumption under pressure. Decision frameworks emphasized early retreat rather than late endurance. These changes did not arise from panic, but from recognition that survival had depended on thin margins rather than robust preparation. The North Sea required this approach. Its danger does not always present as overwhelming force, but as compounded pressure delivered briefly. Near misses revealed that resilience depended less on peak strength than on flexibility and awareness. Systems that survived did so because they bent rather than broke, because responses adapted faster than conditions intensified. Over time, these lessons layered into regulation, engineering practice, and operational culture. Each narrow escape added clarity, closing gaps that had been invisible before. The sea did not change, but the understanding of it did. Safety here became less about assuming control and more about accommodating surprise. Near misses are often forgotten in public memory because nothing was lost, yet in this water they hold immense weight. They map the boundary between tolerance and failure, showing where standards must grow to meet an environment that rarely exceeds expectation for long, but often exceeds it just enough to matter. Control appears strongest where systems are most visible. Modern ships move with quiet precision, guided by sensors that read wind, depth, and position in real time. Bridges glow with data. Stabilizers adjust automatically. Engines respond smoothly to command. From inside these structures, motion feels measured and contained, as if the sea has been translated into manageable inputs. This sense of command is earned. Technology has reshaped what vessels can endure. Hulls flex rather than fracture. Ballast shifts to counter-roll. Autopilots correct heading faster than human reaction. Forecasts inform departure windows, and communication extends awareness beyond the horizon. Compared to earlier eras, the margin between routine passage and failure has widened. Yet this control exists within bounds that the sea defines. Waves are not obstacles to be pressed flat or smoothed away. They are moving expressions of energy, arriving with timing and shape that resist simplification. Stabilization systems can reduce motion felt within a vessel, but they do not remove energy from the water itself. That energy still meets steel, transfers force, and continues on its path. Technology reacts. It does not neutralize. Engines can hold position against current for a time, but the effort consumes power continuously. Hull design can shed water efficiently, but repeated impact accumulates stress. Electronics can guide course precisely, yet guidance assumes conditions remain within expected limits. When those limits shift rapidly, systems respond after the fact rather than before. The illusion of control strengthens when technology works well. Smooth crossings reinforce the belief that capability equals dominance. Each successful response becomes evidence that the sea has been mastered, even when success depended on timing as much as design. This belief carries forward quietly, shaping decisions about exposure and tolerance. Nature does not contest this illusion directly. It allows long stretches where systems perform exactly as intended. Then, it introduces alignment rather than escalation. Forces combine briefly. Wave direction meets current, period tightens, depth constrains motion. The result is not overwhelming power sustained over time, but focused energy delivered in moments. These moments exceed what systems are built to absorb comfortably, even if only briefly. Control ends where reaction time is insufficient. Machines operate within programmed thresholds. When reality crosses those thresholds faster than adaptation can follow, response becomes mitigation rather than command. Systems shift from preventing motion to surviving it. At that point, the sea defines terms, and technology negotiates rather than directs. This boundary does not diminish engineering, it clarifies it. Design aims to buy time, flexibility, and resilience, not certainty. The sea remains an active participant, not a surface to be flattened. Waves rise according to physics that operate independently of intention, shaped by depth, wind, and alignment beyond any single intervention. The illusion of control fades most clearly in retrospect. After passages where systems were pushed close to their limits, understanding settles that success did not come from dominance, but from margins holding long enough. The sea allowed passage, but it did not yield. Technology enabled survival within moving boundaries, reminding those who cross it that control at sea is always conditional, granted moment by moment, and withdrawn without notice when forces align beyond design. Violence in water is not judged by appearance alone. To the eye, one sea may look calm while holding more energy than another that appears chaotic. Scientists approach this quietly, translating movement into quantities that describe how much motion exists, how often it arrives, and how force is delivered when it meets resistance. These measures do not dramatize the sea. They describe it in terms that allow comparison without relying on surface impression. Energy is the first layer. It reflects how much work the water is capable of doing, carried within waves as they travel. A taller wave usually carries more energy, but height alone is not decisive. Speed matters, as does mass. Waves moving quickly across shallow basins retain much of their energy near the surface, where interaction with vessels and structures occurs directly. In deeper water, some of that energy spreads downward and outward, lessening its immediate effect. Frequency adds another dimension. This describes how often waves arrive, the spacing between crests measured over time. Seas with longer intervals allow motion to feel rhythmic and predictable. Shorter intervals compress motion, creating rapid succession that leaves little time for adjustment. Even moderate waves feel heavier when they arrive in quick sequence, each one meeting water already disturbed by the last. Force emerges where energy and frequency meet resistance. When a wave strikes a hull, a platform, or the seafloor, energy converts into pressure applied over a brief moment. Force depends not only on size, but on how abruptly that energy is delivered. Steep waves concentrate impact into short durations, transferring momentum suddenly. This sharp delivery is often what causes damage, rather than sustained height alone. Some seas feel harsher because these elements align more often. Shallow depth keeps energy near the surface. Confined geography shortens wave spacing. Currents modify speed and direction, tightening intervals further. The result is water that applies force more frequently and less evenly, even if average conditions appear modest. The body registers this through constant correction, the need to respond again before settling from the last movement. Scientists describe these conditions using spectra rather than single values. They look at distributions of wave heights, periods, and directions, recognizing that extremes arise from overlap rather than isolation. Violence, in this sense, is not a single peak. It is the density of motion within time and space, how crowded the water becomes with energy. Comparison has limits. Metrics allow seas to be ranked in certain ways, but they cannot capture every interaction. Local geography, human activity, and momentary alignment resist standardization. Two regions with similar energy measures may feel entirely different depending on how that energy is expressed. One spreads motion gently across depth, another compresses it against the surface. Measuring violence in water does not seek to label seas as dangerous or safe. It seeks to understand how motion behaves once conditions align. The numbers describe capacity, not intention. They reveal why some waters exhaust, destabilize, or damage more readily than others, not through spectacle, but through the quiet arithmetic of energy delivered often, close together, and with little room to dissipate. Sound arrives here before sight. It moves ahead of waves and wind, traveling through water and hull long before the surface reveals change. In shallow seas, sound does not sink away into depth. It spreads outward, reflecting from the seabed and returning upward, filling the water column with layered vibration. What begins as a distant disturbance becomes present everywhere at once. Shallow water reshapes how sound behaves. In deep oceans, acoustic energy can travel downward, dispersing into vast vertical space. Here, the distance between surface and seabed is short. Sound waves strike the bottom quickly and rebound, guided back toward the surface. This repeated reflection traps noise in a narrow corridor, amplifying it through persistence rather than volume. Even modest sources linger longer than expected. Storms reveal this most clearly beneath the surface. As wind strengthens above, pressure changes translate into low-frequency vibrations that travel through water with ease. Waves breaking overhead produce sharp, percussive sounds, a rapid series of impacts as crests collapse and reform. These sounds do not remain localized. They overlap and combine, creating a constant rumble threaded with sudden bursts, felt more than heard. Currents add their own texture. As water accelerates across uneven seabed, it produces friction that generates continuous noise, a deep, restless hiss. Sediment shifts and rolls, adding softer, irregular tones. The seabed itself becomes a resonant surface, participating in the soundscape as much as the storm above. Together, these sources create an underwater environment that is rarely quiet, even when the surface appears restrained. For humans within this water, sound becomes an invisible force. Divers experience it through vibration in the chest and skull, a pressure that does not correspond to any visible motion. Crews aboard vessels feel it transmitted through steel, a low-frequency hum that persists without clear origin. Prolonged exposure increases fatigue, not through loudness alone, but through constant stimulation that prevents sensory rest. Animals respond differently, though not without effect. Many marine species rely on sound as their primary means of navigation and communication. In shallow seas, reflections distort acoustic signals, bending paths and blurring direction. Storm noise masks biological sounds, reducing the effective range of calls and cues. Orientation becomes more difficult when echoes return from multiple angles at once. Fish adjust depth and position in response, seeking layers where sound is less chaotic. Marine mammals alter movement patterns, sometimes avoiding regions during intense activity. These changes ripple through behavior quietly, shaped by conditions that leave little physical trace but influence presence all the same. The sound of a shallow, angry sea is not a single roar, it is accumulation, energy reflected, multiplied, and sustained in a confined space. It persists when waves pass and lingers when wind eases. This constant acoustic pressure becomes another layer of strain, one that operates without spectacle. It reminds those within it that force is not always visible, and that the sea speaks most clearly in ways that travel farther than sight, filling water and body alike with motion that cannot be easily escaped. The coast here never settles into a finished shape. It adjusts continually, yielding grain by grain to forces that do not pause between seasons. Cliffs shorten, beaches thin, and dunes migrate inland with steady patience. What looks solid from land reveals itself as temporary when measured across years rather than days. Erosion rates along this sea are higher than many expect, not because the coastline is fragile by nature, but because energy reaches it often and with little moderation. Waves arrive frequently, their intervals short enough that surfaces rarely recover between impacts. Each strike removes small amounts of material, and repetition does the rest. Loss accumulates quietly, without the drama of collapse, reshaping margins through persistence rather than singular events. Shallow water contributes to this pace. As waves approach land, they do not lose much energy to depth. Instead, they retain force close to the surface, delivering it directly into cliffs and beaches. Reflection from the seabed sends motion back toward shore rather than allowing it to dissipate outward. The result is sustained pressure applied at the same elevations again and again. Tides add reach. Rising water lifts wave attack higher along cliff faces and dune fronts, expanding the zone of impact. Falling tides expose newly weakened surfaces to collapse, carrying debris back into the sea where it can be redistributed. This vertical movement widens the area of erosion, increasing contact between water and land across each cycle. Storms accelerate processes already underway. Strong winds drive waves that strike at steeper angles, undercutting bases and opening fractures. Spray penetrates rock, carrying salt that weakens structure over time. During intense events, large sections can fail at once, but even these moments are extensions of longer patterns rather than isolated causes. Human structures struggle to hold against this motion. Sea walls redirect energy briefly, often concentrating force elsewhere. Groins trap sediment locally, while starving adjacent stretches. Each intervention becomes part of the system, altering flow and erosion patterns beyond its immediate footprint. Shorelines respond not by stabilizing, but by shifting the location of change. Long-term evidence records this history clearly. Old maps show villages that no longer exist, roads ending abruptly where land once continued. Submerged forests appear at low tide, stumps preserved where soil has been stripped away. Archaeological layers erode from cliff faces, releasing objects shaped by people who once stood far from the water's edge. These markers do not speak of failure, but of scale. The force shaping the coast operates across centuries, indifferent to ownership or memory. What feels permanent within a lifetime proves flexible when measured against repeated motion. Retreat here is not sudden retreat from a single blow. It is adjustment under constant pressure. The shoreline does not resist so much as negotiate, yielding gradually where energy demands passage. Over time, the land steps back, and the sea occupies space it has already visited many times before, leaving behind a record written not in height or spectacle, but in absence, measured quietly by how far the edge has moved. Rest here is a pause, not a state. Even when the surface smooths and the horizon steadies, movement continues beneath, guided by forces that do not sleep. The North Sea sits open to the sky, exposed to passing systems that arrive from many directions, each leaving an imprint before moving on. Air flows over it continuously, transferring momentum without ceremony, renewing motion even during quiet intervals. Constant atmospheric input keeps this exchange alive. Winds may weaken locally, yet pressure gradients farther away continue to feed energy into the basin. Swells travel in from distant weather, carrying memory of storms long gone. Clouds pass, fronts slide through, and the boundary between air and water remains active, a surface where motion is exchanged again and again. The sea receives this input as a matter of course, rarely given time to settle completely. Once energy enters the system, it does not vanish easily. Shallow depth limits how far motion can sink, keeping much of it near the surface, where it remains engaged with wind and current. Reflections from seabed and coast return energy upward rather than letting it fade. Currents redistribute it horizontally, threading movement across banks and channels. What appears calm often holds residual motion, rearranging itself rather than disappearing. This persistence reveals itself in subtle ways. Swells continue to arrive after winds ease, their spacing widening but their presence unchanged. The surface rolls gently, while deeper layers remain active, pushing and pulling beneath what looks composed. The sea carries yesterday's weather into today, blending inputs across time instead of clearing them away. Calm is therefore temporary by nature. It depends on alignment rather than absence. Winds must not only weaken but remain so across broad regions. Pressure must stabilize. Tides must shift without reinforcing existing motion. These conditions occur, but they are brief. The system is built to accept energy more readily than to release it. Human perception often mistakes this pause for rest. Smooth water suggests stillness, yet instruments continue to record movement. Small waves travel long distances unimpeded, and currents maintain their course. When a new system arrives, it does not begin from zero. It builds upon what is already there, stacking fresh energy onto a base that never fully cleared. This continuity shapes the sea's character. Change arrives quickly because groundwork has already been laid. A modest increase in wind finds water prepared to respond. Motion accelerates rather than initiates. The sea feels alert, quick to shift from calm to active without long transition. The North Sea never fully rests because it remains connected. It is tied to the wider atmosphere, linked to distant weather, and constrained by depth that keeps energy close. Its calm moments are interludes rather than conclusions, thin layers of quiet laid over ongoing motion. In this way, rest becomes a surface condition, not a deep one. The water continues its exchanges, holding energy in reserve, ready to move again when alignment returns. Calm passes gently, leaving little trace, while motion resumes as if uninterrupted, revealing a sea defined less by peaks of violence than by an enduring refusal to go entirely still. Change enters this sea gradually, carried not by singular events, but by shifts in background conditions. Air above the North Sea is warming, and with that warmth comes altered behavior in systems that pass overhead. Warmer air holds more energy and moisture, feeding storms that develop with greater intensity before they ever reach these waters. When they arrive, they carry momentum shaped farther south and west, arriving already charged. Stronger storms do not appear more often in every season, but they appear with different character. Wind fields broaden, pressure gradients sharpen, rain and snow fall with heavier bursts, adding fresh water to the surface and altering density layers below. The sea responds quickly, translating atmospheric change into altered wave patterns and more energetic surface motion. Events that once sat near the upper edge of expectation now arrive closer to the center. Sea level rise adds another layer. Even small increases in average height change how water interacts with land and structure. Waves reach farther inland, touching areas previously spared regular impact. Storm surges ride atop higher baselines, expanding their reach without increasing wind speed. Erosion accelerates not because forces are new, but because they are applied at elevations unaccustomed to repeated contact. Depth shifts subtly as well. Shallow areas grow slightly deeper, changing how waves break and how energy reflects from the seabed. This does not necessarily soften motion. In many cases, it allows waves to retain form longer before releasing force closer to shore or structure. The geometry of interaction adjusts, redistributing stress rather than removing it. Rising temperatures also affect stratification within the water column. Seasonal layering strengthens as warmer surface water sits above cooler depths for longer periods. This alters current behavior and how energy moves vertically. Motion remains trapped near the surface more often, reinforcing processes that already concentrate force where human activity occurs. Conditions may intensify because multiple changes align. Warmer air strengthens storms. Higher sea levels expand the zone of impact. Altered stratification reshapes energy pathways. None of these shifts act alone. Together, they adjust the baseline from which the North Sea responds to ordinary weather. The sea does not become unfamiliar, but it becomes more responsive, quicker to amplify input. This change is uneven. Some years reflect little difference, while others reveal sharper contrast. Calm periods still arrive, yet they sit alongside moments of sudden escalation that feel less isolated than before. Historical records stretch back far enough to show variability, but recent patterns suggest that extremes cluster more often, compressing intensity into shorter intervals. The North Sea has always operated near balance points, where small shifts produce noticeable effects. Climate change nudges those points closer together. The margin between manageable and demanding narrows, not through constant escalation, but through reduced recovery time between events. Energy enters the system more readily and leaves it more slowly. What this creates is continuity, not rupture. The processes shaping this sea remain the same. Wind, water, and depth still govern behavior. What changes is the background against which they operate. Warmer air and higher water quietly raise the starting point. From there, familiar forces act as they always have, but with greater reach, making conditions that were once rare feel less distant, folded more naturally into the rhythm of the sea. Life along this coast has never been arranged in defiance of the sea. It has been shaped alongside it, adjusted slowly as conditions shift and return. Settlements sit back from the most exposed edges. Roads curve where straight lines would fail, and structures face the water with practical restraint rather than ornament. Adaptation shows itself in small decisions repeated over generations, choices guided by observation rather than optimism. Coastal communities respond first through flexibility. Homes elevate incrementally, harbors reshape their entrances, and protective works are placed where erosion proves persistent rather than symbolic. Some areas retreat deliberately, allowing land to return to water where defense would demand constant repair. Others reinforce selectively, accepting that holding every meter is neither feasible nor necessary. Adaptation here does not seek permanence, it seeks longevity through adjustment. Daily life reflects this awareness. Work schedules bend with tides, and weather windows. Buildings favor durability over elegance. Materials are chosen for resistance to salt and motion, understanding that exposure is continuous even when the sea appears quiet. These choices rarely draw attention, yet together they form a living response to a dynamic boundary. Offshore industries have undergone similar shifts. Oil and gas platforms, wind farms, and shipping operations have evolved as understanding deepened. Design philosophies moved away from rigid resistance toward resilience and redundancy. Structures accept movement, absorb stress, and prioritize safe failure modes. Maintenance cycles shortened, monitoring systems expanded, and operational thresholds lowered to reflect how quickly conditions can escalate. Wind energy offers a clear example. Turbines are placed with careful spacing to reduce interference, foundations driven to tolerate shifting sediments, and blades engineered to endure irregular gusts rather than average winds. Access windows tighten, and crews rely on rapid deployment and retreat rather than prolonged exposure. Efficiency improves not by ignoring danger, but by working within it. Shipping follows a parallel path. Routes adjust seasonally, vessels diversify capability, and decision-making emphasizes timing over brute endurance. Industry persistence here does not come from resisting the sea's character, but from aligning with its patterns as closely as possible. At the center of this adaptation lies human persistence. People continue to live, work, and build beside this water not because it has grown gentler, but because familiarity has matured into respect. Knowledge accumulates through shared memory, passed quietly rather than declared. The sea remains present in planning conversations and unspoken calculations, guiding behavior even when not mentioned directly. Persistence here is not stubbornness, it is negotiation. It accepts limits, revises expectations, and continues forward without demanding control. Each generation inherits both the risk and the understanding that comes with it, refining responses through lived experience. Living beside a violent sea becomes less about conquering it and more about fitting within its rhythm. Change is expected, disruption anticipated, and calm received without assumption. This approach does not eliminate danger, it reduces surprise. In doing so, it allows human life and industry to continue at the edge of a force that has never agreed to be anything other than what it is, shaping coexistence through patience rather than certainty. Scale misleads easily at sea. Larger bodies of water seem to promise greater danger, while smaller ones suggest familiarity and control. The North Sea disrupts that assumption quietly, demonstrating that size alone offers little guidance about behavior. What matters instead is configuration, depth, and connection, the way energy enters, moves, and remains within a system. Here, a relatively compact basin produces conditions that rival or exceed those of much larger oceans. Shallow depth keeps motion close to the surface. Open exposure allows weather systems to arrive fully formed. Boundaries reflect rather than absorb energy. These factors combine to show that intensity is not diluted by limited area. It can be concentrated instead, shaped by geometry rather than distance. This lesson extends outward to other regions. Semi-enclosed seas, continental shelves, and marginal basins often share similar traits. They respond rapidly to atmospheric input, amplify wave behavior, and hold energy where interaction with coastlines and infrastructure is most direct. The North Sea becomes a reference not because it is unique, but because it reveals these principles clearly, without hiding them behind vast scale. Ocean science draws from this clarity. Models refined here improve understanding elsewhere, highlighting how shallow systems can behave unpredictably despite extensive monitoring. It emphasizes the importance of local factors over global averages. Predictions improve when depth, bottom shape, and prevailing wind alignment are treated as central variables rather than secondary details. The sea also corrects long held misconceptions about violence in water. It shows that danger does not require towering waves or tropical storms. It can arise from moderate height, delivered frequently, from timing rather than magnitude. It demonstrates that energy accumulated gradually can be as impactful as energy released suddenly, shaping environments through persistence rather than spectacle. Another misconception concerns familiarity. Studied waters are often assumed to be tamed by observation. The North Sea reveals instead that understanding does not eliminate variability. Measurement increases awareness of complexity rather than reducing it. Each dataset uncovers new interactions, reminding scientists that prediction operates within probability, not certainty. This understanding reshapes how ocean systems are compared. Rankings based solely on maximum wave height or storm category lose relevance. More informative comparisons examine energy density, frequency, and retention. The sea teaches that harshness emerges from alignment when multiple moderate factors combine within constrained space. For science, this becomes a humbling lesson. Control remains limited even where data is abundant. Precision improves forecasts, yet does not simplify reality. The North Sea acts as a laboratory where limits are visible, where small shifts produce outsized effects, and where assumptions based on scale dissolve under observation. Its contribution lies not in drama, but in correction. It encourages a view of oceans as systems defined by interaction rather than size, by structure rather than reach. Through this lens, seas everywhere become more understandable, not because they are predictable, but because their complexity is acknowledged. The North Sea teaches that intensity belongs to arrangement, and that safety is never guaranteed by familiarity or scale, only shaped by how energy moves through water that remains, always in motion. Respect for this sea is not loud. It lives in habits, language, and decisions made before leaving land. Along its coasts, memory gathers quietly through stories passed without embellishment. Names of storms linger longer than dates, and places are recalled by what was lost there rather than what was built. These memories do not seek drama. They persist because repetition gave them weight. Cultural memory here forms through accumulation. Fishing families recall seasons that failed to return boats. Harbors keep plaques and markers that few visitors notice, but locals read instinctively. Loss is not framed as anomaly. It is woven into identity, shaping how work is planned and how risk is discussed. The sea becomes a constant presence in conversation, even when not mentioned directly. Sailors still fear this water, though fear here is not panic or superstition. It is awareness sharpened by familiarity. Routes are known, charts are detailed, and forecasts are precise, yet caution remains central. Crews speak of the sea in practical terms, measuring windows rather than distances, timing rather than ambition. Fear becomes a working tool, encouraging restraint where confidence might otherwise press forward. This fear persists because the sea rewards no complacency. Long periods of routine crossing end abruptly when alignment changes. Experience teaches that survival often depends on recognizing when not to proceed. Decisions to turn back are valued quietly, not celebrated, but respected. The sea shapes reputation, not through bravado, but through judgment. Over time, this shared understanding becomes a quiet acknowledgement of limits. Technology improved, vessels strengthened, and communication expanded. Yet acceptance remains that control extends only so far. Mariners do not speak of conquering these waters. They speak of crossing them, of timing passage so conditions allow rather than challenge. Respect also lives in silence. After incidents, investigation replaces speculation. Names are read, lessons absorbed, and work continues with minor adjustments rather than sweeping declarations. The absence of spectacle reflects understanding that the sea owes no explanation. What occurred is treated as part of a long pattern rather than a singular affront. This restraint carries forward into how the sea is taught and remembered. Training emphasizes margin and patience. Novices learn early that confidence without caution erodes quickly. Stories highlight near misses as often as disasters, reinforcing that survival often rests on choosing restraint over persistence. The North Sea commands respect because it continues to demonstrate relevance. It does not rely on myth or distant history. Its presence is felt through current practice, shaping daily decisions across generations. Loss remains part of its narrative, not as warning, but as reminder of scale. In this way, respect settles into coexistence. It neither romanticizes danger nor dismisses it. It recognizes that familiarity does not soften force, and knowledge does not erase consequence. The sea remains what it has always been: active, responsive, and indifferent, and those who live and work beside it carry this understanding forward, not as fear alone, but as quiet discipline shaped by memory and limit. Knowledge accumulates here steadily, layer by layer, without changing the sea's behavior. Instruments refine measurements, models grow more precise, and records extend farther back than any single lifetime. Yet understanding does not press the water into obedience. It clarifies patterns without flattening them, revealing structure without granting authority over it. Science distinguishes between knowledge and control. Knowledge describes how energy moves, how waves align, how storms grow and decay. Control would require the ability to interrupt these processes, to redirect motion at scale. The North Sea makes this distinction visible. Every new data set improves anticipation, but none alters outcome once forces align beyond human thresholds. Mastery remains impossible because the system is open. Energy enters from the atmosphere continuously, arriving from distant regions that cannot be isolated. Depth and geography constrain movement in ways that amplify rather than moderate response. Feedback loops develop quickly, stacking motion faster than intervention can respond. Even perfect awareness cannot remove time delays, and those delays define the boundary where control ends. Attempts at domination give way to refinement. Forecasting improves resolution, but not certainty. Engineering advances absorb stress, but do not eliminate it. These efforts succeed by reducing harm, not by eliminating risk. The sea does not resist conquest because it defends itself. It resists because it does not acknowledge intent at all. Modern science accepts this quietly. Its language shifts away from prediction toward probability, from command toward resilience. Models express ranges rather than guarantees. Safety margins replace promises. This acceptance does not represent surrender. It represents maturity, an understanding that complex systems operate beyond linear influence. In this framework, understanding becomes a way to coexist rather than to rule. Knowledge guides timing, design, and response, allowing humans to place themselves where conditions permit rather than demand passage. The sea remains active, but engagement becomes selective. Intervention focuses on adaptation, choosing positions that endure rather than force outcomes. Acceptance reshapes ambition. Instead of seeking final answers, science refines questions. Instead of total coverage, it prioritizes critical zones. The goal becomes not to master the sea, but to reduce surprise. By understanding thresholds and sensitivities, scientists and operators learn where caution matters most and where flexibility provides safety. This approach echoes across disciplines. Climate science, oceanography, and engineering converge on the same conclusion. Control at scale is not attainable, but influence at the margins is meaningful. Small adjustments produce real benefits when aligned with natural behavior. Resistance without alignment produces rapid failure. The North Sea demonstrates this lesson repeatedly. It allows long periods of apparent stability, then reveals how quickly control dissolves when assumptions harden into certainty. Each encounter reinforces that understanding is dynamic, never complete. In accepting this, science does not diminish itself. It becomes more precise in purpose. It acknowledges limits without abandoning inquiry. The sea continues as it always has, shaped by forces larger than intention. Knowledge keeps pace alongside it, not to conquer, but to remain present, observant, and prepared within a system that will never submit, yet can be understood well enough to live with. This sea ends where it began, in familiarity that never becomes simple. It lies beside cities, trade routes, and daily weather reports, close enough to feel known. Yet certainty never fully settles around it. Patterns emerge, are measured and described, then drift out of reach when conditions align just differently enough. The North Sea accepts attention without granting answers. Routine crossings continue above water that holds more energy than it shows. Ships depart on schedule, crews follow procedures refined by experience, and instruments confirm what looks manageable. Beneath that normalcy, motion stacks quietly. Forces accumulate without announcing themselves, waiting for timing rather than scale. What makes this sea distinct is not constant chaos, but how easily intensity hides within the ordinary. Violence here rarely announces itself in advance. It resides inside frequency, depth, and alignment, not spectacle. Most journeys pass without incident, reinforcing trust in repetition. Then a familiar route tightens unexpectedly, and what seemed stable becomes demanding within moments. These shifts do not rewrite the sea's nature. They reveal it briefly before routine resumes. Understanding grows alongside this rhythm. Knowledge improves margins and shortens response times. It offers clarity about how motion behaves, where thresholds sit, and why outcomes change so quickly. What it does not offer is closure. The sea does not explain why one crossing proceeds smoothly while another resists, even when conditions appear similar. That ambiguity remains intact, carried forward with each passage. Calm returns often enough to invite reflection. In quieter moments, the water smooths and movement softens, allowing space to notice scale and continuity. The same forces that trouble it are also what keep it alive, exchanging energy with sky and coast in steady conversation. Calm does not contradict its power. It exists alongside it, brief and genuine, without promise. This closing is not an ending in the traditional sense. The North Sea continues beyond the frame of explanation, active regardless of observation. It resists final interpretation because it does not operate for interpretation at all. It moves according to physics that never pause to reassure or warn. What remains is attention, to notice how quickly routine can shift, how knowledge guides without ruling, and how familiarity does not flatten force. This awareness does not ask for fear or mastery. It asks only for presence, for seeing what is close without assuming it is settled. If this quiet journey through the North Sea has held your curiosity, you are always welcome to remain a little longer. There are other waters, other hidden patterns, and other calm explorations waiting to unfold. A like or a gentle subscribe helps keep this slow space of science and reflection moving forward. Until then, let the sea rest where it is, unresolved and patient, continuing its work without explanation, while we carry its lessons softly into the quiet that follows.